Good, great. People are introducing themselves in the chat. Welcome, everybody. This is Wetlands Watch Lunch and Learn here on Friday afternoon. Please introduce yourself in the chat, as you can see that others have done so as well. We're not going to do introductions today due to the high number of participants. So be sure to introduce yourself in the chat. All right, I think we should get started. Welcome to Wetlands Watch's Lunch and Learn series. Today, we are going to hear from Sierra Hildebrandt, who's going to talk about living shorelines and the use of oyster castles in living shoreline design. We're so grateful that Sierra is going to be presenting today and know that she has a lot to share in the work that she's been doing. So first, before we do that, I wanted to introduce Wetlands Watch team. My name is Mary Carson Stiff. I'm the executive director, and I'll ask Shireen Hughes to introduce herself next, please.
Hi, everybody. I'm Shireen Hughes. I'm assistant director of Wetlands Watch, and I've been working with Stacy McGraw and Sierra. We've been mentoring her as a Sea Grant Fellow for the last year and a half, I think. It's been a while. So we're excited to hear what she has to share.
All right, Stacy.
Good afternoon, everybody. I'm Stacy McGraw, Green Infrastructure Program Director for Wetlands Watch and co-coordinator of CBLP along with Shoreen. And yes, we've been working with Sierra in her fellowship and then also with the Living Shoreline Collaborative.
You don't even hear what these people are saying.
I'm gonna just mute everybody, so please do mute yourself as you're joining. Okay, wonderful. Well, I would like to introduce Sierra to you all. Sierra Hildebrandt is a current PhD student in the Ecological Sciences program at Old Dominion University. She's in the Wetland Plant and Restoration Lab under Dr. Taylor Slowey. In addition, she is a Virginia Sea Grant Graduate Research Fellow working with Wetlands Watch, as Shireen mentioned, to develop living shoreline training material for outreach purposes. Her research focuses on evaluating the efficacy of living shoreline projects to provide shoreline protection and enhance critical habitat. And this work is especially important in Virginia as the default erosion control structure is living shorelines after a 2020 law was passed requiring that this is the case. So we're very grateful to you, Sierra, for your partnership and work with Wetlands Watch, and we're excited to hear what you have to present today. Go for it. You should have full capacity to share your screen and all that jazz.
Okay. Perfect. Hi, everyone, and I'm going to figure out how to share my screen real quickly. And that I clicked share screen. Can everybody see my full screen?
Yes.
Yes. Okay, great. Okay, so thank you everybody at Wetlands Watch for the introductions, and thank you for inviting me here today to talk about some of my ongoing research. As it was mentioned, I'm a current PhD student and Virginia Sea Grant Graduate Research Fellow at University. And today I'll be discussing my ongoing research assessing shoreline protection and oyster habitat provided by oyster castle living shorelines, tools, approaches, and preliminary results. And before I begin, I just wanted to give you a brief background of why I'm here and how I got here, I guess. So I grew up in a coastal community along the Back River in Hampton, Virginia, where I have been lucky enough to call home for the past 28 years. As a kid, I explored the marsh in the background of this photo and its winding creeks. I caught crabs, went swimming with my family, did really all the fun things a kid can do on the water. However, my home and neighborhood look drastically different today. The expansive marshes that provided years of adventure and protection are eroding. We've had an increased frequency and intensity of storms, as you can see here. And this has resulted in our traditional shoreline structures failing and our houses needing to be repaired after floods. And unfortunately, what my home is experiencing is happening to coastal communities all around Virginia and the rest of the world, as we can see in these photos. Up in that top left-hand corner, you have Skip up in Norfolk, Virginia. You have the same failing structures down in Florida, all the way across the United Kingdom, and then down to Australia. And growing up in this area and experiencing these impacts of climate change head-on have very much impacted my career choice. In 2018, I received a bachelor's in biology from Old Dominion University. In 2021, I received a master's in biology from Hampton University. And then now I'm at ODU working towards a PhD in ecological sciences.
Sierra, I am
Yes.
so sorry to interrupt you, but we can see your whole screen. And I
You can
think that
see-
some of the participants might miss some of your slide deck. Do you think that you could,
What can you not see on this slide? Can you see everything on it?
so yes, but we can see all of the Zoom controls. And so some of your content is blocked. So if you do new share at the
Okay.
top,
New share.
click on the actual button. Okay, and if you do that,
My
or actually,
desktop.
no,
Power.
go all
Do
the way.
Microsoft PowerPoint.
Perfect. Yes,
it.
that's great.
Now are we good?
Wonderful. Thank you so
Okay.
much.
That's fine. I'm glad you caught me earlier until I was in the middle of everything. Okay, now I have to figure out where my slide button is. Okay, so while I was completing my master's research on oyster restoration, I really came to enjoy restoration science, but I wanted to expand my research in a way that would provide valuable information to coastal communities such as Hampton that were facing these impacts of climate change and dealing with erosion. And that kind of led me into doing my PhD research, and that led me to doing or switching from oyster restoration into more living shoreline work. And you can see here in these photos, these are some of the first living shorelines I started working with the Elizabeth River Project and the Chesapeake Bay Foundation. And for those of you who may be unfamiliar with what a living shoreline is, it is a type of shoreline management practice. As you can see here in this figure, we have a continuum from gray harder techniques to greener softer techniques. Your gray harder techniques are your traditional coastal structures, so your seawalls, your bulkheads, your revetments. And then towards that greener softer side, or those more nature-based solutions, you have your beach nourishment, your sills, and your vegetation. And towards this greener softer side is where our living shorelines come in. And historically, coastal structures have been used to protect our coastal communities, but through research, we have learned that these harder techniques do have negative impacts on our environment. These structures deflect instead of absorb wave energy, causing scouring of our river bottoms. That scouring then can reduce our turbidity as well as our intertidal habitat. And during installation of these structures and during storm or after storm events, we have resuspension of sediments from the bottom that can release trapped nutrients, heavy metals, and other toxic substances. And additionally, these structures physically alter our wave regime, our sediment dynamic and depositional processes, further reducing our critical habitat and changing our ecological interactions from our subtidal to our intertidal up into our buffer zones. So as a result of this research and kind of learning what these impacts are, we have seen an increased use of greener, softer techniques, such as our living shorelines. And in living shoreline designs, natural habitat features such as our oyster reefs and our salt marsh vegetation have become a large focus in Virginia to offset the accelerated deterioration and loss of salt marsh and oyster reef habitat, but also to restore these critical ecosystem functions and services provided by our natural habitats, but specifically shoreline protection. And so while we saw in that previous shoreline management practice figure that shorelines can range in design from only planting to a more hybrid approach, a living shoreline design is really going to depend on your coastal setting. But in Virginia, our living shorelines and the living shorelines that I research are created by placing sand along a shoreline to restore your marsh elevation, placing of structural and organic matter to help marsh establish, and then also placing vegetation to further help stabilize and trap those sediments. And a popular component in living shoreline designs in coastal Virginia with areas that have suitable habitat are oysters. And historically, native oyster shell has been considered the optimal hard substrate to use for restoration. However, oyster shell availability has declined over time. We've also seen an increase in price due to that decline of availability and increase of restoration. So as a result, we have seen a number of alternative hard substrates that can be incorporated into a living shoreline design. And these have really been developed to mimic your oyster habitat. Examples of these include your quick reef down in North Carolina, exoforms or natrix also out of North Carolina, and then oyster castles out of Virginia, as well as reef balls or domes. And for my research today, I will be focusing on oyster castles. And for those of you who may be unfamiliar with what an oyster castle is, this is a type of oyster-based concrete product, as you can see in this photo, that can be stacked to create a low profile or low elevation structure along a shoreline, and it aims to mimic an intertidal oyster reef. Once in the water, your free-swimming oyster larvae recruit and settle or cement themselves onto these structures, just like they would a native oyster shell, and then metamorph into a spat or juvenile oyster. And through this repeated process of settlement, theoretically and over time, we have oyster castle reefs that, just like a natural reef, form large aggregations that are self-sustaining, providing adaptable coastal protection while enhancing oyster production and salt marsh habitat. This all sounds perfect, right? However, sometimes when you go out to these living shoreline sites that have these oyster castle structures, you go out and you say, wow, this looks amazing. I have great growth here. It's doing everything I anticipated doing. But then other times you go to the same site, install the same time, the same year, and it doesn't look so great. You don't have that great oyster growth. If anything, you may have mud structures, 8 years later. And we see the same thing with these newly installed sites. We have that wow factor after 1 year, and then others after 1 year, absolutely no growth. So this is kind of what got me interested in living shorelines, because if you are a homeowner or property owner and you want to install an oyster castle living shoreline on your property, your first priority is shoreline protection. However, that adaptable part of the shoreline comes from that ability of that oyster structure to keep recruiting, keep developing over time. So I really wanted to understand why we are seeing these differences and how these oyster castles are developing over time and further impacting your shoreline protection. But the first step to my research was figuring out where all these projects had been installed. And with trying to locate these projects, I started talking and working with Wetlands Watch, as well as the Virginia Institute of Marine Science, Virginia Department of Conservation and Recreation, and I learned about the Virginia Marine Resource Commission Habitat Permit Database that houses all of our shoreline permits for Virginia. And through these permits, different databases have been developed, but I was really interested in developing a database that would be more accessible to a homeowner or somebody for monitoring purposes. So I have started to develop a database, working backwards from 2023 up until 2015, and adding in projects that had already been reviewed by VIMS or Wetlands Watch, but also adding additional information into those, such as, what was the primary and secondary reason of these projects? Did this project install wetland vegetation, or did it install oyster reef? If so, what was the square feet, the linear feet, what species were used, what substrate was used? And then from this information, I was actually able to create a similar map as just how VIMS and VMRC, or VIMS and Wetlands Watch, have developed, trying to understand where these projects are located. So with that database, I went and pulled all of our living shoreline projects that incorporated oyster castles into their design. And while I was only looking at projects from back till 2015, so some of the data that I had from VIMS went back to 2010. So I actually had oyster castle installation dates from 2023 back to 2010. And from this information, I learned that we have over 65 Oyster Castle living shorelines installed in Virginia. And although we have all these Oyster Castle sites installed, we have little to no long-term monitoring data, making it difficult to determine whether or not these oyster castles are effective as an erosion control technique, but also for habitat restoration, and really how these two goals are being met over time. So at ODU, my PhD research aims to bridge this gap in our understanding of how living shorelines are providing that coastal protection by evaluating a 10-year-old oyster castle reef shoreline chronosequence to hindcast that long-term monitoring that, again, may not have occurred since installation. And for my research, I was interested in two objectives. My first was to assess the functionality of oyster castle reef living shorelines in reducing the shoreline erosion. And then the second was to evaluate that oyster reef development on oyster castle reef living shorelines. So of those 65 oyster castle living shorelines that you all just saw, near ODU are 54 of those sites. However, in this area, majority of our shorelines are urbanized and privately owned. So to get permission to access 54 privately owned oyster castle sites, I needed to ask permission. And I started just by reaching out to all of our local nonprofits who had installed these projects, working with them to get access to the landowners' properties. And with their help, I was actually able to get access to 24 of these living shoreline sites. And to give you an idea of what they look like, they vary. They age in range, or they range in age from 1 to 10 years old. They span over 5 different localities. They range in length from 7 to 145 meters, and they also range in width from 53 to 130 centimeters. So going back to my two objectives, I'm using two extremely different approaches depending on my research objective. And to assess the shoreline protection of oyster castle reef living shorelines, I am using more remote sensing and a tool developed by the USGS called the Digital Shoreline Analysis System. And then to evaluate our oyster reef development, I'm using more traditional field-intensive approaches and collecting data on ground using our traditional biological monitoring and surveying approaches. And for this remote sensing work, I use the United States Geographical Survey Earth Explorer, which is a free online tool that you can use to locate satellite imagery. And then using this tool, I located high resolution images for each of my living shoreline sites to encompass the shorelines from 2010 all the way up until 2021. Pictured here is an example of what a shoreline image would look like that I would have downloaded from Earth Explorer. Okay, so using a combination of ArcGIS Pro and ArcMap, I delineate my shorelines prior to installation and after installation, and then using that DSAS tool in ArcMap, I can calculate rates of shoreline change to determine if our shorelines were expanding or if they were eroding before and after installation. And for my study, I calculate the endpoint rate, which is just the shoreline change or the distance between the oldest and the youngest shoreline. So moving into our preliminary results, again, I want to say that these are preliminary because this is only 7 sites pictured. But we can, with this endpoint rate value or the shoreline change rate, we can start to understand, what's going on at these sites. So we're going to look at this graph, and we have our sites in the order of age on the x-axis. So the NS site is our youngest and the SE is our oldest. And then on the y-axis, we have our shoreline change. So the shoreline change value calculated in the DSAS program. And each site rectangle you have here has 2 box plots. First box plot is for the before, and the second box plot is the after. And we're going to start by just looking at our pre-installation box plots. And I want to point out here that our red line on the graph shows our 0 value. So all points above that 0 are positive, and they're showing expansion, while those below the 0 are negative and showing erosion at site. So we found in our preliminary results, looking at these 7 different sites, that we had an average endpoint rate that ranged, or we had an endpoint or shoreline change rate that ranged between negative 5.52 meters per year to 1.44 meters per year. And we saw an overall trend of erosion, as you can see indicated by each of these red arrows. However, now we're going to switch to our post-installation values indicated in the green arrow, and we can see that we had a shoreline change rate that ranged between negative 0.14 to 3.96 meters per year. And we saw an overall trend of expansion across all of our sites. Further, when we started to analyze this data, we found that we had a significant change between a shoreline change before and after installation at 6 of our 7 sites, as you can see in this figure indicated by the black asterisk. And then further, when we actually compared this pre and post, we found that all sites that had the 6 sites that experienced our changes also had a significant effect between the before and after. And I want to point out here, because I do not say it again, when we're comparing this before and after, we're seeing a good thing here, because this change from erosion to expansion is showing that our living shorelines are either maintaining or they're accreting over time. So again, although these are preliminary results, these are good results, because we are seeing that our Oyster Castle living shoreline designs are reduced shoreline erosion after installation, but they're also continuing to provide that protection 10 years later. However, this is still one portion of this project, and we still need to understand how habitat goals are being met. So moving into our oyster reef development side of my research, I sampled 16 Oyster Castle living shoreline sites between June and September of 2023, and at each site, I used a 0.25 meter square quadrat that was placed randomly at locations along the landward and channel side of the reef, as well as high and low elevations on the reefs, for a total of 12 quadrats. And in each quadrat, I collected data on oyster reef metrics to include number of oysters alive and dead, oyster shell heights and lengths, and the percent cover of oysters, barnacles, mussels, and also bare. So what was not covered by anything. Then using surveying equipment, we also conducted data on reef elevation. We grabbed total length, our average height and average width of each of the Oyster Castle living shorelines. So the physical structures that were in the ground. And with this data collected, I was first interested in seeing if we saw an increase in oyster density with increasing site age. So we're going to look at our preliminary results on this graph. You have the site age on the x-axis and our oyster density on the y-axis. And each bar plot in the graph represents our different sites. And what we found is that our oyster density was highly variable. We really didn't see an increase in oyster density as we moved towards our older sites. And when we analyzed the data a little further, we also found that our Oyster Castle age had no effect on oyster density. So now I'm starting to investigate other variables, such as the distance to the mouth of the river, distance to our nearest oyster reef, reef elevation, our reef length, reef width and area, really to understand the observed variations in our oyster densities and try to determine what is limiting oyster reef development. And ideally, once we have all this data together, we can start to figure out which variables may be impacting and put them all together to see how these variables are impacting success of our Oyster Castle reef living shorelines. So that leads us back to our question, how are Oyster Castle reefs developing over time? And based on our preliminary results, we still need more data and I still need further analysis. However, I think it's important to note that our Oyster Castle living shorelines are providing oyster habitat, and they're providing habitat at densities that meet oyster restoration goals. As there's a black line on this graph here that shows just where our 50 oysters per meter square line would be. And you can see that of our 16 sites, 15 of those sites are above, if not well above, what you want an average density to be along a site, showing that these oyster castle reefs are in fact providing oyster habitat and doing it at a density anticipated for or needed to sustained oyster population. So yay. And I do just want to restate again that these are preliminary results. I still have a number of looping shoreline sites to analyze for my shoreline change analysis and a couple oyster reef sites left for my oyster reef development, because of those 23 sites, those 16 sites, the other ones were underwater every time I went to go visit during the end of the season. So we have to make sure we get back to get accurate oyster counts. And additionally, this is also only two pieces of the research I'm working on. I also am looking to understand how oyster castle living shorelines are enhancing our marsh vegetation health. So one day in the future, hopefully I can meet with you all again and tell you what that side of the project is telling us. And then just finally, because obviously I'm working with Wetlands Watch, one of the main goals of working with them and doing the partnership through Sea Grant was trying to understand how I could use my science to inform, practice. So something that I have been working on with the help of Wetlands Watch is a way to actually, again, implement my research, but also others' research into an easily accessible guidebook or a handbook that could be used by somebody interested in installing a living shoreline. And my aim of this book is just to take that more complicated ecological, biological research and put it into a format that's easily translated into design considerations or site evaluations. And with that, I'd like to thank everybody who has helped me, all my committee members, others in our lab, as well as Dr. Eric Yando's lab and some of his students, the Virginia Sea Grant, VIMS, Linehan River Now, Elizabeth River Project, and of course, Wetlands Watch.
Thank you, Sierra. That was wonderful. We have some questions in the chat. They've been coming in throughout, and so we'll go through those questions first. And
Okay.
then if y'all have questions.
Where's your car? I was getting ready to say.
Where's your car? That's a good question, not related to this topic. So as people have questions, there's also an opportunity to come off mute and ask your question. You can use the raise hand function and we'll create a queue that way as well. Okay. The very first question is from Jeff Corbin. So Sierra, what is the definition of your shoreline improvement in meters per year? What about landward migration?
Jeff, are you still on?
I am.
Can you repeat your question?
Can you hear me?
Yes, I can hear you.
Sure. I can't remember the exact terminology you used, but one of your graphs that was showing before and after of the shoreline improvement, it had meters per year improvement. And how is that measured? Is that actually land that's being increased? Yeah, keep going back.
Got a lot of slides now. So this graph?
We got shoreline change, yeah, meters per year. So is that, 2 meters per year? I mean, that's a lot of improvement in a year. Does that include what was filled and planted with the project, or is that what is now?
Yeah, that includes whatever was filled and planted. So it was the shoreline with the vegetation prior and then to where the vegetation is now.
Okay, so that is not natural accretion.
It's
as a
not
result
natural
of the project.
accretion, correct?
Overall improvement. Okay, thank you.
Right. Thank you.
Okay, Barbara Gavin has asked, where is the KDA site located that has such high oyster density?
So that site is located right across the water from an oyster reef. So let's see if that site is on here. it's in the Lynn Haven, and it's directly across from a historic oyster reef. And it's right at the mouth. It's actually on a very, I would say, energetic wave shoreline.
Okay, great. Jessica Steelman asks, are there any hypotheses as to why some sites show no growth and some show great growth, as you first highlighted?
That is why I started looking at this distance to nearest reef as well as distance to mouth, because at the time I'm not collecting, in-depth water quality, so I'm not grabbing salinity and temperature, so I can't take those aspects into account kind of, but this was kind of a way for me to say, okay, well, how is maybe salinity impacting based on distance to mouth, and then also distance to nearest oyster reef, because I would anticipate that you're not going to have oyster growth at a site unless you have a nearby population that's sourcing it. So that was kind of what I'm be put into the ground.
Looks like Sierra has just a little bit of a connection difficulty. So when she becomes more animated and it's caught up, we'll ask her to repeat the last couple things that she's said. If you have additional questions, please remember to use the raise your hand function to ask, which you can do. Oh, we lost her altogether. Oh, my lands. She'll be back. Let's see. Anybody have any experience with using oyster castles in your community, or if you are an actual contractor, successes or lessons learned that this group might find helpful? This is a great opportunity to fill some space. Oh yeah, Barbara, go ahead.
Hello, everybody. Sorry, I have to swap over cameras. Hi.
Hey.
Yeah, Sierra has done a lot of this, the Elizabeth River. Oh, lots
Sorry.
of recordings. And a lot of the sites that she's looked at were older, which is fantastic to see so much great oyster growth on them. Two of the things that we learned, I think, that were helpful too in partnerships with CBF was you can install them in areas that are a little bit soupier. So a lot of times you don't want to put rock or things that are heavy in areas where they'll sink, but being able to put down filter fabric and control the loss of sand and keep the elevation. Jeff, I know we've talked about that in the past, the difference between North Carolina and Virginia, where in North Carolina, you don't need to put sand or sediment behind the structures that you're putting in. But for us to get that pollution reduction credit of creating a wetland, we're putting in sand, installing wetland plants, doing the whole shebang at once. And then I put in the chat too. So we've used thousands and thousands of oyster castles over the years. But Allied Concrete did recently get sold, who manufactures these oyster castles. So their Charlottesville facility they still have their Chesapeake facility. We are, fingers crossed, very hopeful that they'll be bringing their molds to Chesapeake
This must be
here soon.
contagious. Bad Zoom connections. There, Barbara's back. Okay, great.
Did you catch any of it?
Yes.
Good.
Great. So Sierra, welcome back.
I'm sorry.
Don't worry.
I came to campus to have good internet, and apparently I still get kicked off.
No
See,
problem.
maybe it's something here then, since we're right next to you.
It's just Norfolk. We'll blame Norfolk.
So Sierra, you were just answering Jessica's question about you know, some sites having great growth and others not.
Did you catch any of what I said or no?
Yeah,
Okay, okay.
we did. Maybe the just a final wrap up thought, and then we'll move to
Yeah.
that.
I guess I hypothesized that it was, nearby oyster reefs was going to play a role, but also obviously your environmental parameters. So that's why I was looking at distance to the mouth as a factor for salinity.
Thank you. You've done a great job interpreting all the data too and making it easy to follow.
Thank you. I try to.
The next question is from Elizabeth Hamburg. She asked, if you have a living shoreline, do oyster castles help preserve the shoreline from deteriorating? And do the castles actually degrade very much?
I think it will depend. At a lot of the sites that I am going to, I honestly don't see much deterioration. I mean, even with the oysters cementing themselves, growing, like I know there's still a structure under there. However, if you have a storm come through and knock a castle off, that's a different problem.
Great. Kelsey English asks, do you have any predictions on what factors might be the most influential to reef development? For example, do you notice anything about these sites with higher development that the other sites were lacking?
Yes. Can you repeat the question so I can think about it again?
Absolutely. Do you have any predictions on what factors might be the most influential to reef development? For example, did you notice anything about these sites with higher development that the other sites were lacking?
Right. So I think that the sites that have the most recruitment and growth, it seems like, again, those are ones that are at locations that are having better environmental parameters. So ones that are having maybe the best salinity, ones that aren't having freshwater runoff from the land. Again, I don't know right now if I can say which one I think is maybe the most determining factor, because again, it's a system, everything is interacting with each other. So it's going to be hard to, I think right now, make a general statement.
No worries, that's great. Okay, so now we're going to pop to in the Zoom room. Vince has his hand up. Hey, Vince.
Hi.
Hey.
I just wanted to mention that we've done a lot of these over the years and using oyster castles. And the two things, the recruitment, I agree entirely with Sierra on that the recruitment is better in the environments that the oysters already are doing well. And then the second thing I wanted to just point out is the importance of getting the elevations right. And Barbara mentioned that you can do it on a soupy bottom with the fabric. And that's also, when you're doing it on a soupy bottom with the fabric, taking into account that they are going to sink a bit and making sure you get the elevation right, allowing for that sinkage is important in terms of the protection value.
Yeah, and I will say, I feel like a lot of the newer sites, like honestly, after 2015, you don't really see a lot of the sinking that I see in our much older sites. And I think that comes from more of a design standpoint, just learning from what a site looks like. So.
Thank you, Vince. Vince is with Lynn Haven River now, doing quite a lot of these projects too as well. Okay, so Tom asks, who makes the castles and how much do they cost? Do you know?
Concrete makes them, but as Barbara, I came in at the end of your thing so that they may have just been sold and purchased by somebody else.
Yes, but they'll still have their molds. It's just whether or not they can get them to Chesapeake, which they seem confident that they can, luckily. They come on a pallet and it's $72 per pallet. And typically they're around $6 to $8 a piece, incorporating freight into that. Ideally, also, if they're coming to Chesapeake, maybe the freight won't be so high because they won't have to travel all the way from Charlottesville.
Thank you, Barbara.
Mhm.
Any other questions for Sierra? There are a lot of experts on this call. So this is a great group of people. You have their captive audience. And so if you have any questions, it seems like you could ask certainly here. Okay, CW, please go ahead.
Hello, everyone. I'm with the city of Norfolk and have installed quite a few of our living shorelines. Haven't used oyster castles, but just having installed and seeing what we have seen with a natural progression of oyster growth, is wondering if we can look at maybe the exposure of the oysters and the oyster castles to the tide cycle, during different locations. The tides act differently, have different heights, different depths. Maybe exposure to air versus water over time may have a play to it. Also, with the age of 1 to 10 years, there have been some times where we had some really cold freezes during the wintertime. Don't know if that would also see an effect on the growth. Maybe it stunts it. I'm not quite sure, but those are just kind of two of the things I'm thinking of that you could probably look without having to actually physically go back out there. Obviously, you can go back and look at tide data and stuff that nature. And also maybe there's enough reports that go out with water quality throughout the years of the area. So maybe you can go back and look at that data and see if any of that data may come into play as well over the yearly research. The really data that comes into play from all the research that goes on in this area, anyways. Those are the kind of things that may also attribute, but may not.
No, I have thought about these too, and I have actually talked with other folks at ODU and the Chesapeake Bay program to see what type of environmental data they have. So they have water, they have salinity, or they have not, of course they have water, they have salinity, they have temperature, and they have a whole suite of other variables that they have been monitoring, but I only have them at some sites, but taking those into play. And then also what I'm looking at doing is I have water level loggers to look at inundation at each of these sites. So trying to see, like, again, this is again a snapshot of, how often they're being inundated or flooded, but seeing how that plays a role.
Thank you, CW. Mary Hill, hey Mary, has asked, how does this impact submerged aquatic vegetation? Good question. How do oyster castles, how does their use in living shoreline design impact submerged aquatic vegetation?
So I'm not a permitting person. I do not design shorelines. I do not install them. I would anticipate that, if an oyster castle is being placed on a mud flat, that they're not being placed on submerged aquatic vegetation because they're protected. So I think we would run into a problem if people were doing that. But I have not looked at maybe the, positive impacts of having an oyster castle living shoreline or living shoreline itself instead of a, traditional seawall bulkhead. And I would anticipate that having that, again, allowing for that dynamic movement would actually help seagrasses.
Norfolk Wi-Fi strikes again.
Oh, am I out? Am I still here?
Is she moving on yours? Yeah. Okay, so it's me.
It's fine for me.
No.
Oh, nope, there it goes.
Oh no.
Oh, yeah. You're going back and forth. I'm in Norfolk too, so I understand. I'm actually an ODU student. But I get it.
Can anybody hear me?
Yes, you're good.
Okay.
If you're having some trouble with your connection, turning off, I know it's nice to see you talk.
I can turn off.
Turn off your monitor, that might help.
Okay.
Got a lot more questions popping up.
I'm glad I only had, a less than 30-minute talk then. Questions.
So the next question is about permitting. What kind of permits from the city do you need? And if you're doing this, who is actually doing the installation?
So again, I do not permit I have helped with installation, but I do not install. Our installers could be contractors or the nonprofit groups with volunteers. If you're doing a living shoreline, you're going through your general permit application, and then you're applying for either, the general permit 1 or general permit 2 for a living shoreline. That is very simplified.
And then I would add, the question is, who does the installation? And that varies. So sometimes the nonprofits do the installation with volunteers. Sometimes there are contractors doing the installation. I added that we're part of the Living Shoreline Collaborative locally. And through a NIFWIF grant, we were able to develop a training for contractors. And a number of the people on this Zoom meeting were either instructors or participants in that. And the reason we did that was to make sure that there are enough people who know how to do the work.
Great, thank you, Shireen. Jeff is asking a question about the material that actually makes up these oyster castles. And he says that Allied Concrete defines oyster castles as essentially modified concrete blocks. But he says that he's also heard that they may incorporate shell material. Does anyone actually know the recipe makeup of the material composition of these blocks?
I think that at one point they were using crushed oyster in their recipe. And I do not know if they still do that. I feel like at one point they have switched. And I don't know if Barbara is still on, or maybe Vince, somebody else who
Yep.
works
Barbara,
more closely with them.
yeah, so Barbara said shell, limestone, and concrete, and Vince has raised his hand. So Vince, if you have any more insight, go ahead.
I'm of the same understanding, is that they used to use shell, they don't anymore. The other thing that I'd like to add is that we have been doing for the years projects where we grow oyster spat. We call them spat catchers. It's a cage of oyster shells and then a cage of some other substrate. And we've used concrete, and it has performed almost as well as the oyster shell on attracting spat.
Interesting. Great. Thank you, Vince. Christine asks, is there an issue with oysters growing on the oyster castle? Do you run into just concrete structures with no oysters at any sites?
So occasionally we will come to a site that doesn't have recruitment, or maybe again it's just they're too small, I can't see them yet, because I'm only going out to these sites one time and visiting, so they could have just been installed last year, so they may be only 1 year old. But we also do collect percent coverage for the mussels and the barnacles and the bear. Christine, I don't know if you're still on, if you can rephrase what you mean by issue, like competition.
Well, sometimes we run into issues where an oyster castle or any type of oyster structure is put out that's concrete and their algae gets on top of it, and then they don't get as much oyster recruitment, and then ends up being more concrete with algae, and really oysters don't get on the structure. So I didn't know with some of the oyster approaches if there's an issue with actually getting oysters to populate.
Yeah, and I'm not sure if, I haven't had many sites that have a lot of algae. If anything, I see more competition with mussels, and it will become more of a mussel castle instead of an oyster castle, and that's that's what I'm going to call it now, a mussel castle. That's I think again, competition, but even the algae I don't see much of. And I had originally anticipated even like tunicates being a problem, because I have those on my shell bags, but I haven't seen those on the castles at all.
I know sometimes on the ready reefs, we've had the problem with when the ready reefs are put out and they're kind of similar to concrete, but they're pyramids, and some people don't get any oysters at all. And so it wasn't their plan.
Right. And I don't know if that's time of year problem they're being installed. Like, are they not put out at a time that you're having active recruitment? I'm not saying oysters are picky, but they're kind of picky in that they don't want it super clean, but they don't want it super dirty for settling. So
Right. Thank you.
thank you.
Barbara, go ahead.
Yeah, sorry, ignore the lawnmowers. I just want to confirm that what Sierra said is right. So we do try to, and Vince, I'm sure it's probably the same for y'all. We try to only put out oyster castles at the right time of year so that we know it doesn't end up getting covered in algae or mussels or whatever it might be. For us, that's basically February/March through September at the very latest.
Very helpful. Thank you, Barbara.
And Vince, I agree with your comment. Mussels are still good. We like mussels too.
Jeannie, or excuse me, Janice.
Hi, yeah, that was correct, by the way, Denise. I was just wondering because I know I've done in the past when I was in like middle school, I learned a lot about oysters in the Chesapeake Bay. Is there any like diseases that you have to worry about with the oyster reefs?
Yes, there are diseases that could be impacting, I would
like-
say not recruitment, but growth, and sustaining that. So
You have to
But-
keep track of that. or, like-
unfortunately, I have not looked at disease.
Okay.
But that has been a thought of mine, and maybe one day if I decide to go down the path of continuing to look at factors that could be limiting their growth, I think disease would be the next obvious step.
Okay, I was just curious.
Thank you. That's a great question.
Any other questions for Sierra?
I just wanted to say it's been a real honor to work with Sierra. She's really knocked it out of the park. I think she's done an amazing job, and it's really been interesting. We consider ourselves kind of a boundary organization that works with, between science and implementation, research and implementation. And the work that we've been doing, when we talk to Sierra, she takes that into consideration and then researches it, and then that research is turned around and informs the actual implementation and moving us all towards more successful living shorelines, which is the ultimate goal. So it's been really we've really enjoyed working with her. And Sierra, I think you did a really nice job on this presentation. Thank you.
Thank you. And thank
Alright.
you everybody else for coming and listening to me. Spending your
Is this
lunch break with me.
presentation going to be shared with anyone, or like, is there a place to look at it?
Yes. We will make the presentation available on Wetlands Watch's YouTube page. We'll also link it somewhere on our website, and we'll send out an email blast that will include the recording. We've had a couple lunch and learns. And so we'll include that in an email blast. We try not to over inundate people with emails at Wetlands Watch. And so it'll be in a condensed blast that will happen sometime next week, likely.
All right, cool. Thank you.
Thank you, Sierra. Excellent job. Thanks for all your work for our organization and for the benefit of so many.
Thank you. And thanks again for having me and helping me with all my work.
Well, hope you all have a wonderful weekend. And thanks for coming to our Lunch and Learn.
Thank you.